What's up, everybody? Welcome back to Unit 4, Worksheet 413. We've done sine, cosine, and tangent to find angles. And in this sheet, all they do is mix up the triangles and see if you can figure out all in your onesie how to use sine, cosine, and tangent to find an angle without them being in a row. Basically, they just mix up the triangles and you got to figure it out. What you're going to learn real quick is that once you know how to label the triangles, you will figure out whether you're going to use sine, cosine, or tangent real quick if you remember SOHCAHTOA, right? Which is just to say our triangles. So sine is so, cosine is ka, and tangent is toa. SOHCAHTOA. So which one is which? The first one, where are we looking? Go ahead and pause the video right now and try both of these, and then unpause and listen to the rest of my spiel, or just fast forward and see if your answer is correct. Okay, so I'm looking in this direction. I see that's opposite, that's adjacent, and that is the hypotenuse. So I'm using A and H. A and H is cosine. So cosine is A over H. 3.4 over 8.952. And I need to find the angle, so I'm using the second function. Hopefully that's all coming back to you. And the angle that I get is 67.678494992. So that angle is 67.678. I'm going to go to 3 decimals because I'm going to run out of space. 67.678. So maybe I want to know now what's up here. So I know that there are 180 degrees total. There's already 90 degrees being used in that bottom corner. That means there's 90 degrees left over between the two angles. So if I do 90 minus the 67.678, that tells me the leftover of what must be in that top corner. And what must be in that top corner is 22.33, Kevin. 322 degrees. The reason that's handy is because now I can look the other direction and relabel my triangle and do the math separately to double check that I get 22.322 degrees. So now I've got opposite and hypotenuse. So I can use sine to see if I get it. So it'll be 3.4 over 8.952 equals second function sine. I'm having a dilly of a pickle over here. All right, second function sine. How do I know that? I just remember this, or I remember this, or I remember this, and all I'm doing is plugging in the labeled numbers into where they go in my equation triangle. So I see in this triangle that sine goes with opposite over hypotenuse, and I just put the opposite over top of the hypotenuse, which means divide. Opposite divided by hypotenuse. And I'm trying to find the angle, and the rule for finding an angle with trigonometry is always use the second function. So the green button in the top left corner of the calculator, the second function, I hit that, I hit sine, and I hit equals. So 3.4 divided by 8.952 equals, and then hit second function sine in your calculator, and you're probably going to get 22.322 degrees, or if I mess that up, you will get the answer. I don't think I messed it up, though. I did it twice to make sure. Okay, now we've got 6.45 and 5.89. Well, I'm going to move some of this stuff around so that I've got space. I need space. Get out of here, all this stuff. taking up all my room. Go on, get. Okay. I have all the space in the universe. I'm looking in this direction, and I see opposite, and I see adjacent, and I see hypotenuse. I don't have hypotenuse. I have A and an O. So which one uses an A and an O? Sine has hypotenuse. Cosine has hypotenuse. Tangent has an A and an O, and I see it is an O over an A. And because I'm getting to try to find the angle, it's going to be O divided by A equals second function tangent. That is my equation every single time trying to find angles. So it just becomes a matter of plugging the numbers in for where they correspond to. 5.89 is the opposite. 6.45 is the adjacent. Top divided by bottom equals green second function button on the calculator. Tangent button on the calculator equals 42.4016501 degrees. Okay, so I'll call it 42.402 degrees. I'll just round to the third decimal. I'm pretty sure that's what the book asked you to do. And if I want to find out if I'm correct or double check my math, I can find this angle by doing 90 minus 42.402. That will tell me the angle over on the other side. Which is 47.598. That's hard to read, but that's okay. And then I can double check my math. I could also use Pythagoras to find the hypotenuse, and then I could use any function because I've got all three sides of the triangle. I can use sine, cosine, or tangent, whichever one I think is the most fun. And don't you dare say that none of them are the most fun. You know you have a favorite. We all have our favorite. Poor cosine being left out. Hey, nobody likes cosine. Let's admit it. Be real. What the heck is going on here? That is not a right angle triangle. There are no squares on here, right? That can't possibly be a square. That doesn't make sense. That can't possibly be a square. And this one's already the angle with the question mark. So I don't have any right angles. Kevin, you told us the trig only worked with right angle triangles. So what the hell am I supposed to do here? If you think you know, pause the video and try. I challenge you right now, pause the video and try to work out the solution on this all on your onesie and see what you come up with. It's called confidence building. Okay, we're back. Let's have a crack at this. So you're right, it's not a 90-degree triangle, but if we want to create a 90-degree triangle, we just cut this bad boy in half, we bisect it, and now, well, now I've got a 90-degree triangle on this side, and I have got a twin 90-degree triangle on the other side. Not too shabby, okay? So now that I know that, if I bisect the triangle and cut it in half, that means that the bottom edge is also going to be cut in half, right? So I cut the triangle directly in half. That means that bottom leg is equal each side, which means I can cut it in half. So 19 divided by 2, I get a 9.5. And over here, a 9.5. Okay? Uh-oh, now we're starting to see what's happening. You see what I'm doing here, right? You got it, right? Yeah, one triangle. Now I need to label the sides. I'm using this angle looking across. I see opposite, I see adjacent, and I see hypotenuse. So toa, ka. Adjacent and hypotenuse. I need to find the angle, which means I'm going to divide and use the second function, which means it is 9.5 is my adjacent, 18 is my hypotenuse, and I'm using cosine, so CA-TOA. Yes, I always sound it out mnemonically like that, by the way. It's something internal. It's some sort of hiccup in my brain and my wiring, and I absolutely have to do it. 58.14456918 degrees. Okay, now we're getting somewhere. So that is my degrees for that bottom angle where the question mark is right there. Perfect, perfect. I can round because I'm going to call it 3 decimals is good enough for any angle I need to work with. So 58.14, 3 decimals, the 5 makes the 4 go up. 58.145 degrees, right? Now, maybe I want to work out the rest of the triangle. If this side is 58.145 and this side is its twin, that means this also is 58.145 degrees, okay? It's 360 if it was a circle. If it's a triangle, it's 180 degrees all the way around. I already have a 90 in the corner. I've got 58.145 in the other corner. That means the leftover is the leftover 90 minus 58.145. And what do I get? $31.855 degrees, right? So this little chunk here is 31.855. But if I want to know the whole top, that would be each side. That's 2 sides, right? So that whole top angle for both triangles times 2 is 63.71 degrees at that top angle. Cool. So that answers all 3 of those triangles. The one big one and the 2 little mini ones, right? That's it. We found all the sides. The only thing that's missing now is the vertical from there to there. And you can do it using angles to find sides, which is what we're going to talk about in the next video, or you could use it with Pythagoras. So now let's mess with your head a little bit. So go ahead, pause the video, read this question, and see if you can work out what's happening. So a bundle of rebar, okay? I could do that. Rig 12 feet apart. Oh, this is great. These are my favorite questions. It means I get a draw. Neat. You didn't know I was an artist, did you? All this teaching, all these math videos, and you had no idea Pablo Picasso was right in front of you. Okay, so we've got a bundle of rebar, magically. It's rigged 12 feet apart, so from there to there is 12 feet. Okay, what next? The rigging is 12 feet long. Okay, so 12 feet. How often do you see uneven slings when you're rigging rebar? The answer hopefully is never or not very often. So if one piece of rigging is 12 feet long, the other one's 12 feet long. From the hook to the bundle, right? So that means the rigging from the hook to the bundle is 12 feet long. What is the horizontal sling angle and what is the included angle? Sweet. Okay, I love this question. Now we got to turn some math that we've been learning into a usable, actual, well, when you rig, this is the kind of stuff that you have to be able to figure out. So what's the horizontal sling angle and what's the included angle? Let's start off with, how are we going to find the angles? Remember what we did in the last question? Pause the video now and see if you can work out what the angles are for the rigging in this scenario. So what I want to do is realize that it's not a 90-degree triangle anywhere, so using trigonometry won't help me. However, if I bisect from the center of the hook all the way through the rigging down the center, now I've got, once again, a 90-degree triangle on that side, which means this side is 6 feet and this side is 6 feet. Now I've created that half of that rigging triangle looks something like that, right? The hook is up top. So the question is, what is the horizontal sling angle? What you may not know yet, depending on where you're at in your course, is that the horizontal sling angle means the angle on the horizon, the horizontal. If your rebar or your structural steel or whatever you're rigging to pick is the horizontal sling angle is the angle that comes off of that. In other words, we're looking for this angle down here, okay? So we're standing at the corner and we're looking across. We see opposite, we see hypotenuse, and we see adjacent. We've got adjacent and hypotenuse, which if I do so, ka, toa, I see that it is cosine, and it is a over h, 6 over 12 equals, I'm trying to find the angle, so it's second function cosine button, right? So 6 divided by 12, second function cosine equals 60 degrees. Did it freak you out when you didn't get a whole bunch of decimals? Be honest with me. Yeah. So that is 60 degrees in the bottom corner. Okay, 60 degrees. 90 minus 60 equals 30. That means this half is 30, but it also means that this whole thing is 60. And then down here, what do we have? Another 60. And 60 times 3 is 180. So what we have is 3 equal angles of 60 degrees and 3 equal sides of 12 feet. What this is telling you, what we've just proved mathematically, whether you know it or not, is that if we have 3 equal legs, 3 equal sides of a triangle, then the angles will be 60 degrees, all 3 of them. So what is the angle of these 3 sides? The answer is 60 degrees all the way around, same as it was in the rigging angles. That's going to come in real handy for you when we get into rigging, and hopefully it was handy for you to realize how we can start using trigonometry in real life, not just as things we're doing in a workbook for no reason. All right, we'll catch you on the next video.